So, a dog food manufacturer has to cut production costs. She wishes to use as little aluminium as possible in the construction of cylindrical cans. In the following diagram, H represents the height of the can in centimetres and X the radius of the base of the can in centimetres. The volume of dog food in cans is 600 centimetres cubed. Show that H can be given by this expression. So, what we're going to do, let's get a pen. Part A. The volume of a cylinder is given by pi r squared, the area of a circle, the base, times h. Now in our case, it tells us that the volume is 600 and r is, the radius is x, so we've got x squared, and the height. If we want an expression for the height, I need to divide by pi x squared. Okay, and then I've shown how we got that expression. Right, next, find an expression for the curved surface area of the can in terms of x, and then simplify your answer. So let's go back here. B. Curved surface area. So curved surface area of a cylinder is given by 2 pi r h, where this is the circumference of the base and this is the height of the cylinder. So in our case here, what we've got is 2 pi x, and then h we can stick in this expression here, so times 600 over pi x squared. And then it tells me I should simplify this expression. So we've got an x. Let's just get a different colour. I can cross off an x on the top and an x on the bottom, so divide top and bottom by x, and so I get left with, let's get the pen, I get left with 1200, that's 600 times 2, times pi, actually, we can also simplify, knock off those pi's, one on the top, one on the bottom. Okay, so we've got, all we're left with is that over x. Okay, that's our expression for the curved surface area. So that was B part 1. Okay, and then B part 2. It asks us, hence write down an expression for A, the total surface area of the can in terms of x. So our total surface area of the can is just what we just got, the curved bit. Add the circle on top and the circle on the bottom. So our area equals 1200 over x. Add 2 circles, and circles are given by pi r squared, or in this case pi x squared. Alright. Oh, not 3. C. On to part C. Okay, differentiate A in terms of x. Alright, let's go down here, make a bit more room. Alright, so that's A. I want f dash of A. Okay, I want to differentiate it. In fact, I'm going to do a little bit of work first. Let's get rid of that. Okay, so before I differentiate, what I'm going to do is just write this out in a nicer version for differentiating. So I'm going to write that out as, that is the same as times x to the power of negative 1, and keep this the same, because now when I'm on part C, now that I try to differentiate this, I'm going to get this times this is negative 1200 x to the negative 2, because that goes down a power of x. And then here, 2 times 2 pi is 4 pi x to the power of 1. And I could actually even write that out. We don't have to do this, but this version tends to be easier to substitute into later on. Okay, so I like to do it. All right, okay, let's see what's next. Long question. All right, part D. So we've differentiated it, and now we need to find the value of x that makes a minimum. All right, so let's go back here. I need to put in my calculator. What do I need to put in? Not f dash of a, but I need to put in the actual function. So I'm going to put this here into my calculator. So 1200 divided by x plus 2 pi x squared. Okay, let's just do a standard zoom and see what that looks like to start with. Well, standard zoom doesn't look too great actually. Alright, let's just try a zoom fit, see what that gives us next. Let's see if that's any good. Yeah, that's not too bad. It gives us this strange function and a little bit here. And what we're after is the minimum. So it looks like this is actually going up here, and this is going up here. So there is a minimum point in here somewhere. So I should be able to get the calculator to calculate a minimum. And that's definitely above the minimum, so enter. And let's just go right along. So the right bound, let's make sure I go far enough and make sure this is definitely going up again. Let's put it over here. Okay, enter. And then guess, enter. So this point here. Alright, so just extend my page. Part D, just want to check the question again. Find the value of x only. So the value of x that gives us our minimum is, can't write, when x equals 4.57, and remember x is a radius and it's in centimeters, so that's our answer to part D. Last bit, I hope. Yep, there we go. Calculate the minimum total surface area of the dog food can. Alright, well we've already got that actually. Alright, so extend the page. So surface area minimum is 3.80574. So to three significant figures, it's 394, and it's an area, so it's centimeters squared. Okay, and I've just got that from here.